Today we're going to learn about distributive properties. Let's fill in our graphic organizer to help us better understand what that means. The definition says that distributive property is a math property that lets you multiply each add-in separately and then add the products. So what exactly does that mean? Let's look at some examples. We have the problem 2 times the parentheses of 5 plus 12. We can multiply the 2 times the 5 and get 10, and the 2 times the 12 and get 24, and then add our products for an answer of 34. So instead of following order of operations, where we would add 5 plus 12 first, we're going to multiply first. This will become more important as we get into algebra. Let's look at another example. 7 times 86. We can break this down into the problem of 7 times 80 plus 6. 7 times 80 is 560. 7 times 6 is 42. And when we add those, we get 602. This use of distributive property makes it easier to solve because we can do 7 times 80 and 7 times 6 mentally. 7 times 86 is much more difficult to solve in our head. Let's look at one more that does use algebra. 5 times x1 plus 2. We're still going to multiply the 5 times the x, but because it's a variable, we can't really do anything but say that we have 5x. Then we multiply our 5 times the 2, which is 10. And that is the solution to this problem because we cannot combine things that do not have like terms. So what is not an example of distributive property? As I mentioned before, distributive property multiplies what's outside the parentheses times each add-in inside the parentheses. So if I were to add first, this would not be an example of distributive property. This would be following on the order of operations. When we have variables, not multiplying times every term is a non-example. If I only multiply the 5 times the 2 and not times the x, I do not get the correct solution. So what are some basic characteristics of distributive property? 1, it uses multiplication as a shortcut. And that's key to remember. And the second thing is that it gets rid of parentheses. Now let's try some examples together. Let's say we have the problem 2 times 4 plus 12. We can use a graphic organizer to help us see how to write this. We put the number outside the parentheses in the box to the left, and we put our add-ins on the boxes at the top. Then we simply multiply the 2 times each addend. So 2 times 4 is 8. 2 times 12 is 24. Now, we have two different ways to write this problem. We can write the answer as a product, which involves multiplication, so that would be 2 times 4 plus 12. But to write it as a sum, we take the two amounts inside the box, say 8 plus 24. And those are the different ways that we can write it. Let's try another example. Again, we put the number outside the parentheses to the left. We put our addends on the top. And then we multiply. 10 times 15 is 150. 10 times 6 is 60. So our answer as a product is 10 times 15 plus 6. And our answer as a sum is 150 plus 60. Which would, of course, equal 210. Now let's try it in reverse. What if we are given the two numbers inside the box? What is the number that goes into both 12 and 15? I know that 3 is their greatest common factor. So if I work in reverse and I divide 12 by 3, I get 4, and 15 divided by 3 equals 5. So now, how would I write this answer as a product? 3 times 4 plus 5. The answer of the sum would be 12 plus, would be 3 times 4 plus 3 times 5. Let's try one more of those. Use the numbers 36 and 60. What is a number that you can divide into both of those? I can think of the number 6. 6 into 36 is 6, and 6 into 60 is 10. So my answer as a product would be 6 times 6 plus 10. My answer as a sum would be 6 times 6 plus 6 times 10. Is there a number that is larger that could have gone into 36 and 60? I could have also used the number 12. In that case, 12 into 36 is 3, and 12 into 60 is 5. That answer as a product would be 12 times 3 plus 5, or 12 times 3 plus 12 times 5.